utilizing monolithic external storage arrays is not the only way to provide shared storage for virtual machines for ESXi hosts. In lesson number 6, we're going to have a look at vSAN data stores that uses a technology that is generally known as hyperconverged storage. That is, placing storage devices internally in each of your ESXi hosts, connecting those hosts with a high-speed network on the back end that allows your virtual machine files to be distributed across several hosts and run your virtual machine on a single host. This way, we provide redundancy of your virtual machine files because those virtual machine files are laid out across multiple hosts, and it also allows the virtual machine itself to be portable to run across all of those hosts that have access to the internal capacity devices that are available in your ESXi hosts themselves. So that's a little bit about hyperconverged storage. Let's have a look at how VMware accomplishes this with virtual SAN or vSAN data stores. We'll look at the architecture of vSAN, we'll look at the requirements for vSAN, and we'll look at something called storage policies, which is a way for virtual machine administrators or vSphere administrators to instruct ESXi and vSAN on the requirements for your virtual machines as they run on storage. So a vSAN data store is a software-defined storage solution. It allows ESXi to tell the hardware how to place the virtual machine files to deliver us the capacity, the redundancy, the performance, and the features that we need for each of our virtual machines. So what we're going to do is we're going to create a vSAN cluster. Now, we mentioned this term cluster way back in module number 2? Way back in module number 2 as we were defining some terms. A cluster is a group of ESXi hosts that can aggregate their resources for CPU, for memory, and now for storage as well. Now we need at least 3 hosts within a cluster that contribute to the vSAN data store that we're about to create. Okay? And within these hosts, we're going to have 2 types of storage devices. We're going to have a caching device and we're going to have capacity devices. The caching devices must be solid state. The capacity devices across the data store across the cluster can be either spinning, and they all have to be spinning, or they can be solid state devices or flash devices, in which case they all must be flash devices. We can call it an all-flash vSAN data store, or we can call it a hybrid vSAN data store, where we have the cache devices as solid state devices and the capacity devices that are spinning disks. We also need a network, read VM kernel ports on each ESXi host with dedicated physical ports that are available to the vSAN storage network as well. Within each ESXi host, we're going to describe something called a disk group. And a disk group has at least 1 cache device and at least 1 capacity device. And disk groups can contain up to a total of 8 storage devices. That is 1 cache device and 7 capacity devices. And we can put up to 5 of these disk groups, totaling 40 devices in total on each ESXi host. Now you can create an ESXi cluster with up to 64 ESXi hosts. So imagine your VMFS or NFS data store, which has a maximum size of 64 terabytes. Well, not true with a vSAN data store. A vSAN data store can contain, like I said, up to a total of 40 disks across 5 disk groups. Each of those disk groups has 7 capacity devices. 7 times 5, that's 35 devices for capacity in each ESXi host, times 64 hosts, times the largest solid-state device that happens to be out there, and that's the size of your vSAN data store. You're talking about many petabytes in this case. Within each ESXi host, like I said, we've got to have at least one disk group that provides one solid-state device for caching and one spinning device or solid-state device for capacity. You've got to have a 10 gig NIC if you want an all-flash vSAN data store. You can get away with a 1 gig disk for hybrid mode with spinning disks for your capacity devices, but it's not a great situation. It's technically supported, but VMware recommends at least 10 gig NICs. Now you have to have some sort of storage controller, okay? Now these storage controllers within each of your ESXi hosts are not going to provide redundancy within themselves. So there's no RAID levels. You don't need RAID 1, you don't need RAID 5, you don't need RAID 6 within the ESXi hosts themselves. We're going to manage all of this through software, and we're going to do all of our parity and striping and those sorts of things across the hosts in your cluster rather than across the disks in an ESXi host. So what we need are RAID controllers either set up in pass-through mode or RAID 0 mode, where each device, each NVMe device, each SATA or SAS spinning disk or solid-state device is accessed as a unique device itself. And we can support SAS, SATA, or NVMe type controllers. And they should all be on the hardware compatibility list for vSAN. Your storage devices, your network cards, your ESXi hosts themselves, and especially your storage controllers should be on the hardware compatibility list for vSAN. So make sure you check that hardware compatibility list before you go and purchase any hardware. Finally, we need some RAM on our ESXi hosts. Now, ESXi itself requires a minimum of 4 gigs of RAM. But if you're actually doing vSAN on those hosts, we require a minimum of 8 gigs of RAM. And vSAN within the host, it's all managed within ESXi itself, can consume more RAM in caching facilities and other things if you have larger and more plentiful disk groups within that particular hosts, up to a total of 32 gigs of RAM itself. Once you've configured this vSAN data store, you can go into the storage view and find your vSAN data store, where you can go to the summary tab and get some sort of idea as to the state of that data store. What are its statistics? What are its capabilities, and so on. In this case, we've got, it looks like a significant amount of capacity, 60 gigs or so of capacity with only 3 gigs used. You can see the full path within ESXi to that vSAN data store. You'll notice that it's in /VMFS/volumes/vSAN:, and then it's got a unique identifier for that vSAN object. It's got 3 hosts. It's comprised of 3 hosts. There's 1 virtual machine on there and no templates at this point. So you can see all kinds of information about that vSAN data store itself. Now, I mentioned before a vSAN object. And a vSAN data store is actually not necessarily block level or file level. This is an object-based system, okay? It's also policy-driven, so you can create specific rules for each of the objects within the data store. Now, I want you to think of the virtual machine files that we've learned about so far as vSAN objects, okay? So there are several different types of vSAN objects themselves. The vSAN home namespace object is comprised of what we would normally think as our VRAM, NVRAM, our VMSD, our VMX, our VMX swap file, and our log files. It's also the virtual machine's folder itself is an object on the vSAN data store. So these are all the home namespace objects. We also have virtual disk objects or VMDK objects. Think of this as your traditional flat VMDK, very large files. By default in a vSAN data store, all of our virtual disks are thin provisioned. We also have a swap object. So this is think of that as your .vswp file. We have a vmem object for our snapshots. Thank you. And then we have our snapshot deltas. We haven't talked much about snapshots yet. That's actually coming in the next module, so stay tuned for information on snapshots. So virtual machines created on vSAN data stores include one of most of these different types of objects. You're going to have a home namespace object. You're going to have virtual disk objects. You're going to have swap objects, right? And in vSAN, you can actually make those thin provision swapped objects. You're going to have VM memory objects. We're going to have performance data objects as well. Okay? You can even create within a vSAN data store an iSCSI LUN that can be exported and seen as an iSCSI target if that's something that you have use for.